Okay, so let me conclude by saying that the lesson, the great science often happens when scientific theories interact, scientific discipline interact, new technology become available. And now, but let's go back to the original question, and I finesse that question by saying that let me not answer the great science question in the logical manner, but just do it by analogy. But let's go back and think about the question we start, that what is great science? And now, I think we all agree it must have deep impact and something that is just fun. I think it's not going to, at least until it has great impact, cannot qualify as to be called great science. And now, what is the impact, the potential impact of quantum computing? And one hot topic in quantum computing is called quantum simulation. And the quantum simulation, we already hinted at the simulation using quantum computers. But even without a full computer, it is conceivable that you could use one quantum system to simulate another. And so the trick is that there are quantum systems that are easier to control, and there are quantum systems that are difficult to control, but are extremely important. And we cannot directly work on the problem that we want, but there may be systems which are similar, but they are controllable. So it is possible to simulate the question we want by using a controllable system, and that's a hot subject. And now this simulation can help design new material and test physics theory and so on. And don't overlook this, because one of the original motivation that Richard Feynman stated was that physical quantum theories are extremely difficult to solve, even if you have the equations at hand. Its consequences are very hard to obtain. Using classical computers, people suspect that you cannot do it in less than exponential time. However, if you have the quantum equations, and if you can simulate to solve those equations, then you would have obtained something extremely valuable. I mean, there are, for example, different physical theories for superconductors. And even if you have the different theories, it's very hard to know which one is correct. And so because you don't know what the solution is. If you have the ability to do the quantum simulation, then you'll be able to obtain numbers from them. And then you can compare and make progress. And now, here is something that I think also a great science should have this. It should uplift the human spirit, independent of what the technical details. I think that one must be a great science. One must be able to communicate the idea of this great science, and its goal, its utility, and its impact to people who are not in the field. And I think that in quantum computing, what we are doing is the following. 100 years ago, physicists began and actually understood a very large part of the physical world with quantum mechanics, and so we know the language, and except that we don't have any native speakers we can talk to. And now the situation right now it's similar to, say, in the middle of the Pacific, there is a primitive island, and there are the tribes who actually they talk to each other in the quantum language, and so by using our microscope and lasers, we have been able to get hold and to communicate to those tribes. And we can tell them, why don't you do this quantum dance for us? And when they do, they would factor the large integers and leave it on the beach of the island sand. And I think that this is the first time. I think that must be in millions of years. If you look at all the life beings, they all communicate using digital, because everything, the animals, the plants, everything is simulated by digital signals. It's only in the last 30 years, and now we have the ability to communicate using the quantum language. So I think this is very uplifting. I think we are doing something that really belongs to the history. Okay, thank you very much.